Hello, Algebra 2A, and welcome to day 1 of Lesson 53, where we are performing a composition of functions. One thing we'll have to review is how functions work. So, for example, a function could be f of x equals 2x plus 5. So a couple things about function notation. So the name of the function is f. X represents your input, and then this piece over here, 2x plus 5, represents your function rule. To evaluate a function, you take a number and you input it into your function rule, and that's communicated through this number that's now replaced where that x was. So this would mean that you take 3 and you apply it into the function rule. 3 is also called your input, so we input that into our function rule. Now instead of 2x plus 5, we have 2 times 3 plus 5, which now results in that the function at 3 is going to give us an output of 6 plus 5, which is 11. So just a couple of reminders about how functions work. 3 represents your input, and 11, then the final result is going to represent your output. I'm having trouble writing that, but that would be then your output. That should be an O right there. So that is how we can evaluate a function. Today our learning target is to apply and evaluate a composition of functions. A composition of functions is evaluating two functions in succession. So evaluating a function, finding an output, and then that output becomes the input into our second function. So how the sequencing works is our composition of functions is written f of g of x. The function that is inside of the f function, in this case g of x, that is our first function that we are going to perform. So we are going to take some input and we are going to put that into our g function. Once we do that input, we are going to get a result called your output. And that was like what we did just above there, just to kind of review how these functions work. But now we're going to go in succession. We are going to go through a second function. So g of x, I've already completed that. I've got my output. Now that output becomes the input that is going to go into my next function. So we're going in succession, 2 functions in a row, and then our final result is we are going to get another output. So since we are doing 2 functions back to back, when we get that output from the g function, that now becomes our input of our f function. And then our final result would be an output after we run it through the f function as well. Composition of functions are not commutative. So that means that if I do f of x of g of x, it's not going to be equal if I did g of f of x. And here I did the g of x function first, and then it took that input, put it into the f of x function. I cannot flip that around and have it give me the same result. And we'll see some instances of that is not commutative. So we are going to find a composition of functions 2 ways. We are going to input a value to find the composition, then we're also going to find a composition in terms of x. So first, just a couple other pieces of information. So composition of functions is going to be written as f of g of x, and that x could be also a number. So what this stands for is our g of x function is now inside of our f of x function. That means that the g of x function is going to be input into our f of x function. It also means that the g of x function is what is evaluated first. And then the f of x, whatever we get for the result of g of x, that's what's going to be evaluated second. So the f of g of x is how I would pronounce that, and then that would stand for that the g of x is going to be worked with first. So we work with the function rule of g of x. then that result is going to go into our f of x. So let's look at our first f of g of 4. So the first thing that I would do then is I would take and find out what is g of 4. So g of 4 is going to be a 4 put into the g function rule, which is 3 times 4, which is going to equal 12. So 12 is going to be the output that I get with that g function. Well, like from above, the chain reaction is now 12 becomes the input into that next outside function, which is the f. So now I'm going to figure out what is f of 12. F of 12 put into the function rule is 2 times 12 plus 3, which all said and done, I do 2 times 12 plus 3 gives me 27. So following along, I've got an input that was 4. Then we get this output that was 12. That output now becomes the input into my next function. I'm just doing another function back to back, and I get my final output. So there's our action that happens to complete our composition of functions. We can also find composition of functions using x. So we can do that in terms of x. So here I have f of g of x. So f of g of x. So what this now is saying is take the g of x function and then input it into the f of x function. Well, we don't have a number to evaluate into g of x, but we do have the function rule. So when we're finding a composition of functions in terms of x, we are going to take the g of x function rule and we are going to input that into the f of x. So g of x is equal to 3x. That's the function rule up here. So now I'm going to take that value, 3x, and I'm going to put that into the f function. So that would look like this: 2 times 3x plus 3. And we would simplify anything we could, which gives us 6x plus 3. So there would be my composition of functions. So you can input anything you want into a function, including other functions. So we took the g of x function rule and we input that into the f function rule, and we got a result of 6x plus 3. Lastly, to finish up, we will take a peek at example 2. It says, let f of x equal x to the third minus 2x and g of x equal 3x. Evaluate the composition f composed of g of 2 using 2 different methods. Well, this is the first time that we've talked about the composition symbol, which is that open dot. But f composed of g of x, it's just the same order as we talked about above. That's going to be f of g of x. So there's going to be what we're going to follow. And just like before, the g of x then is the function that's going to be done first, and then the f of x function. So heading back to the g function is 3x, so we'll go g. Our input they want us to use is 2, so g of 2 is going to equal 3 times 2, which is 6. Now that output becomes the input into my f function. So I'm just going in order. So the g of x was inside. I do that first. Now I'm going to go f of 6. Take that output, becomes the input. We're going to get 6 to the third power minus 2 times 6. And 6 to the third power is actually going to be 216. 216 minus 2 times 6, which is 12. That's going to give us 204. So there would be our final output. So f of g of 2, we input into the g function, gave us the output of 6. That output becomes the new input into my f function. We get 204. Well, that'll wrap up day 1, and then we'll be continuing to practice these same ideas into day 2, which also looking at how these compositions are not commutative. Thanks for joining, and we'll see you next time.